All right, guys, your essential question for today is how do we determine the critical points and extrema of polynomial, of any function, really? And so your main word here is critical points. We're going to be looking at things called maximum minimums. And I'm going to give you the definition of point of inflection, but we don't really use that until you take AP Calc. Point of inflection is something we need in calculus. But for this class, we're really just going to be looking at maxes and mins, and we're going to talk about the difference between something called an absolute versus a relative, and I'll show you that also. So here's the vocabulary, if you want to just take a look at it. So critical points are defined as those points on your graph which a line drawn tangent to the curve is horizontal or vertical. That's kind of misleading. So let me just give you my definition. Critical points are either a maximum, a minimum, or a point of inflection. So these three pictures at the bottom represent that. So for example, right here, this would be a critical point where my mouse is, right there, because that's a minimum of that function. So that would be my critical point. All right, over here on the right, this would be my critical point right here where my maximum is, because that is a maximum right there. And so that's where my mouse is, that's my critical point. Now, the one that, again, that we're not going to cover in here, but it's covered in calculus, is something called a point of inflection. A point of inflection is whenever your graph changes from, okay, let me classify this. Guys, this is what we consider to be cup up. You see how the graph is opening up? That's what we call cup up. This right here is called cup down because the graph is opening down. A point of inflection is when your graph changes from cup up to cup down, or vice versa, or from cup down to cup up. But does everybody agree? Right here where my mouse is right there, you see that's the point where my graph changes from its opening upwards, but then right here, now it's opening downwards on this side. So that's what we call a point of inflection. And so that would be my point of inflection. All right, so let's take a look at an example right quick. So this one has already been done for you. Notice that this graph is plotted, so it's already done for us. And I went ahead and I found the extrema. And again, I'm going to show you how to find those extrema on your calculator in 1 minute. But I just wanted to drive this home really quickly. So right here, what would you classify this point as? It's a minimum. That's right. Good. Absolute. What about this one right here? Ooh, relative max, right? And then I'm going to look right here. See, there's no, it keeps on going up, so there's no absolute max. And then what about right here? All right, relative min. Okay. All right. Now, for this, guys, in order to write my intervals of increasing and decreasing, I have to know where my critical points are, because my critical points are where the graph changes from increasing and decreasing. So my second task right here is to be able to write what my intervals of increasing and decreasing are. So let's do that. I'm going to do that right quick right here. Remember, to talk about your intervals of increasing and decreasing, you have to read the graph from left to right. So starting on the left-hand side, what's the graph doing first? Decreasing, and then increasing, and then decreasing, and then increasing. So what I like to do, guys, is I like to put that. So decreasing, and then increasing, and then decreasing, and then increasing. If you do it this way, you'll never get confused. So read it from left to right. Decreasing, increasing, decreasing, increasing. Now, what you're going to do is your intervals are basically a starting point and an ending point. So go ahead and put parentheses for each one of these. And like I said earlier, your intervals of increasing and decreasing always start with negative infinity, and they always end with positive infinity. You're probably thinking, well, why is that? Well, remember, you're reading the graph from left to right. Since this graph keeps on going forever, what's it going to go to if it keeps on going to the left? Negative infinity. What about if it keeps on going to the right? Positive infinity. So that's why our graph always starts with negative infinity to positive infinity for the intervals of increasing and decreasing. Well, now you're probably wondering, well, what numbers are going to go inside these other spaces that I have right here? Well, this is why you have to have those critical points, because once you've got these critical points, all you do is look at the x values and go in order. So you see this first x value is negative 2.25. So this first blank is going to be negative 2.25. And whatever that number is, it goes in this blank also. So negative 2.25. The next x value is negative 0.07, so that goes in this blank. And so then that also goes in that blank also, so negative 0.07. And then the last number is 1.57, so put 1.57 right there, and whatever that number is, it goes in this blank also. All right, so let's take a look at this example. and grab your graphing calculator and put in the function 5x cubed minus 10x squared minus 20x plus 7. What I have here now, guys, is my cubic function. And so there's my function. And the way I'm going to do is I can visually see that this is a maximum, which is relative, and this is a minimum, which is relative. But I need to know what those points are. So what I'll do is I'll hit Menu, I'll go to Trace, and then I'll go to Graph Trace. So Menu, Trace, and then Graph Trace. And if you notice, if you press the little bullseye comes up, if you press to the left in my case, it will tell you where my maximum is. My maximum is at that point. And so what I would do is I would graph this on a piece of paper, and I'd go ahead and write down that point. And so this point is negative 0.667, comma 14.4. And so then I'll do the same thing to find my minimum. So trace, graph trace. I'd move the cursor until it says, your calculator will say minimum. And so there's my minimum value of 2, negative 33. All right, so getting back to it, let's go back to the PowerPoint. And I made a PowerPoint for this, but if you look, there's my graph. And so again, you can just get the image and it's right there. All right, so when I do this, let me show you what my intervals of increasing and decreasing would be. Circle the x values, so those are my x values. And so then you'd literally write out, I'm going to put it right here so I don't have room, increasing, decreasing, increasing, and then it's going to go from negative infinity to positive infinity, and then to fill in the blanks, I'm going to do it in black so I can see it. So the first number is negative 0.667. That number starts over right there. The next x value is 2, and that goes there. So that will be my intervals of increasing and decreasing for that graph. So it's pretty straightforward, and I think that that is it. All right, I'm going to